Assalamu alaikum. This presentation is an assessment for sustainable architect past, present and future module. The assessment is done by Anwaar and Aisha. The assessment focuses on educational building. UAE National Agenda and UAE Vision 2021 focus on the major sectors affecting UAE future and its nation. Education represents the main pillar in shaping the future of generation and country. Objectives of this assessment are to establish historically framed timeline of education buildings and evaluate the sustainable characteristics in UAE. To identify the sustainable features by visiting two schools in different timelines in past and now. Besides that, to create comparison perspective between the two schools to understand the sustainable and comfort levels which has been done in that period. Finally, to assess 5 strategies that will maximize influence in both comfort and energy saving. Sharjah is the second largest emirate in UAE with an area of 2,590 km squares. It is the only emirate linking between all emirates. The sun path diagram reflects the position of the sun that have a major impact on the heat gain of buildings and solar energy systems. The desired orientation of the building considering the use of spaces within the building. As well, all comfort measures will rely on the wind direction during the operation period of the school. This through the calendar year between September and June. The oldest type of education was Katatib by Mutawwa. He or she teaches girls and boys the Holy Quran and Hadith. He offers humanity services and religious process to ensure people follow the right Islamic procedures. Moving forward to the second era in education institution development, Al-Ahmadiyya School celebrated its 100th anniversary as one of the oldest schools in UAE and the first local school. It was founded in 1912 by Sheikh Ahmed bin Dalmouk. The area of the school is 528 meters squares with 2 stories. A journey to the school can be a remarkable chance to realize the simple Emirati architecture aspects based on the local basic materials of wood, palm trees, stems, stones and mud. Classrooms were in both floors to ensure that it fit for more than 300 students as recorded on the 19th. The classrooms were separated by wooden panels. Wind tower, local terminology called Barjil, which provided smooth airflow circulation between inner spaces and outer climate. On the other hand, windows played a great role in 2 dimensions, lighting and airflow within the spaces. It was made of natural local materials of gypsum with variety of textures and patterns. The roof of the building was made of sandalwood poles covered with palm leaves, sarouj and gypsum mixture. The poles were used horizontally with 25 cm separation space. It was used as well on the walls with 4 meters in width. Decoration of the school was made of gypsum with geometric and Arabic scripts written in windows, doors, courtyard, columns, and entrances.
Our school is Fatma Zahra High School for girls. It's a modern school built and operated since September 2017. The school is located in Sharjah, Al Garain area, and is occupied by 1,000 female students of grades 10 to 12 and around 80 teachers and admin staff, utilizing a built-up area of around 8,000 square meters. The school design was an approved typical model representing the 4th generation of schools in UAE. The design of the school is famous for having finger-style design that can be expanded if required. The school models are designed without considering site condition, orientation, and requirements that must be addressed for each area. There was a huge glazed entrance facing the south direction on the school entrance and lobby. Moreover, each school classroom is occupied by 28 students, and the classroom have windows that can provide daylight and ventilation.
In this presentation, 6 strategies have been explored. They are orientation, insulation, glazing, shading, renewable system, and istidamah. First strategy is orientation, which has a great impact on energy in both cooling and heating. 4 orientation scenarios were examined: 0, 90, 180, and 270. The selection of the optimum orientation depended on the minimum values of annual solar gain and annual external conduction gain in kilowatt-hour per meter squares. The orientation of 180 is the optimum choice due to the minimum values of annual solar gain of 5.8 kilowatt-hour per meter square and annual external conduction gain of 10.1 kilowatt-hour per meter square. Second strategy is insulation. In this strategy, the optimum orientation of 180 was considered as baseline. 2 scenarios were examined: hollow blocks and thermal blocks. The first scenario of hollow blocks had a U value of 2.80 watt per meter square Kelvin, which is higher than the baseline of ASHRAE of 0.71 watt per meter square Kelvin. Moreover, the energy percentage is minus 1.23, meaning that the building is losing energy. On the other hand, the U value of second scenario using thermal blocks is 0.28 watt per meter square Kelvin with energy percentage of 8.83, meaning that the building is saving energy. This, the thermal block scenario, is the optimal insulation option. On the other hand, the third strategy is glazing. In this strategy, both orientation of 180 degrees and insulation using thermal blocks were used as baseline. 2 options for glazing were examined: double glazing and triple glazing. The first scenario of double glazing had a U value of 1.70 watt per meter square Kelvin and energy percentage of 12.81, meaning that the building is saving energy. The second scenario of triple glazing had a U value of 1.24 watt per meter square Kelvin and energy percentage of 14.01, meaning that the building is saving energy. This means the triple glazing scenario is the optimal glazing option.
The fourth strategy, shading. In this strategy, orientation of 180 degrees, insulation using thermal blocks, and triple glazing were used as baseline. As the school provided massive shading in the main gathering outdoor area, it was important to focus on the shading on the spaces where students and teachers spend most of their time, classrooms. The energy percentage saving after adding shading canopy along classrooms' windows have reached 14.29. The fifth strategy, renewable energy using PV system. In this strategy, orientation of 180 degrees, insulation using thermal blocks, triple glazing, and canopy shading were used as baseline. The proposed PV system will generate 47.34 kilowatt-hour peak that will accumulate 99,210 kilowatt-hour per annum, considering a panel size of 1.7 square meter, covering 384 square meter in an angle of 20.5 degrees all year towards the south direction above the roof of the school, with total number of panels reaching 226. The energy percentage saving after adding PV panels have reached 18.65. The sixth strategy, istidamah rating system. The school was designed in 2011 and constructed in 2016. The istidamah system was not implemented during the design and construction stages. Thus, The Istidama strategy to achieve 1 Pearl will assume the steps supposed to be taken and considered for the schools to achieve 1 Pearl rating, or it helps the future schools that will be designed and constructed to follow equivalent strategy. There are 20 mandatory criteria to achieve 1 Pearl for any project. Criteria 15 and 16 have been achieved using the application of energy model IES. Some of the mandatory criteria specifies requirements for schools such as 11 and 18, while other mandatory criteria are general to all buildings. Schools of the future. A survey had been conducted asking students' parents to answer one simple question: what is future school? The results of 252 parents resulted on having 126 parents defining smart school as fully equipped facility with smart tools. 58 parents understood future schools focusing on space and artificial intelligence, while 43 parents considered smart schools as fun, and 25 parents struggled to understand what would be a future school is. After examining the future school definition, we have explored the criteria that affect the education and learning experience. The first is the shift from horizontal to vertical schools. The second is the focus on green schools. Third is the enforcement of customer journey mapping. And the fourth is the need to shift schools from typical to extraordinary. As a conclusion, showing the results of the strategies applied increased the energy saving in the building significantly.